Okay, today we're going to be studying multiplying monomials. It's page 410 in your book. We're going to start out by defining what a monomial is. An expression like 1/20th times s squared is called a monomial. A monomial is a number, a variable, or a product of a number and one or more variables. An expression involving the division of variables is not a monomial. Monomials that are real numbers are called constants. So let's go through and let's make a monomial. Okay? Here is a monomial. It's a variable. Here is a monomial. It's a number. Okay? 5x would be a monomial because it's a product of a number and a variable. This would not be a monomial because it involves division of variables. Now if you had x divided by 2, could you write that to where it's multiplying a number times x? Well, yeah, that would be the same thing as 1/2 times x. So that would be a monomial. Okay, now we're going to do example 1 where you identify monomials. You're going to determine whether each expression is a monomial. If it is, you're going to explain your reasoning. Okay, let's look at -5. Is that a monomial? And give the reason why. Do the same thing for p plus q, x, c divided by d, and then a, b, c to the 8th over 5. Pause the movie until everyone has an answer. Okay, did you say yes for -5? It's a real number, and it's an example of a constant number. Did you say p plus q was? It's not because you're not multiplying. That would really be a binomial because you have two terms added together. X is yes. What about c divided by d? Remember, it can't be if they're divided by another variable. And then a, b, c to the 8th over 5. Yes, because see, you can write that divided by 5 as times 1/5. Good job. Okay, before we do example 2, we need to review some past learning. Remember, if you have 2 to the 5th power, the 2 is the base. The 5 is the exponent. Whoops, spelled it wrong. Okay, what is this 5 telling us about the 2? Are we supposed to multiply them together? You're right, we are not. It means that we're going to multiply 2 times itself 5 times. So this really means, different color, 2 times 2 times 2 times 2 times 2. The 5 is the number of times you multiply the base number, which is 2, times itself. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Okay? Now let's say you have 2 to the 3rd power times 2 to the 5th power. Well, the long way is to say, okay, that's 2 times 2 times 2, that represents 2 to the 3rd power, and then times 2 times 2 times 2 times 2 times 2, that's 2 to the 5th power. Now how many times were we multiplying 2 times itself? 1, 2, 3, 4, 5, 6, 7, 8 times. So this is 2 to the 8th power. is there an easier way we could come up with 8 besides working it out like this? I know Nathan, I know you understand, you too Nick, that it would be 2 to the 3 plus 5 power, which is 2 to the 8th power. If you add these, you get the answer. Okay? Anybody have any questions? Good. Let's do example 2. And let's do green. So example 2, we want to simplify the expression. The directions are important because if you don't read the directions, you might do a process but not answer the question. Okay, and the problem is 5 x to the 7th times x to the 6th power. Now, is this 5 an exponent? What is it? What's it called? That's right, it's a coefficient. 5 is the coefficient. This means 5 times x to the 7th, and these parentheses together means it's times x to the 6th. So, it's still going to be 5 times. But what did I find out up here? That if it's the same base, I can add the exponent. So this is really x to the 7 plus 6 power, which will give me 5 times x to the 13th power. That wasn't so bad, except there's another example. This one was A, and this one is example B. A little bit more challenging, but you can do it. It's 4a b to the 6th times negative 7a to the 2nd b to the 3rd. Okay. Now what are the 4 and the negative 7? What are they called again? Coefficients. So these are multiplied. This is 4 times a times b to the 6th. It's negative 7 times a squared times b to the 3rd. So I can multiply the 4 and the negative 7 together. So 4 times negative 7. I'm going to kind of group the coefficients and the variables, the like bases, the powers with the like base. So this is a squared. So a times a squared, and then b, this is times b to the 6th times b to the 3rd. I know you're asking, are you going to have to do it this way on your homework? For the example, we'll do it this way. Okay, 4 times negative 7, negative 28. Something good happens to a bad guy, that's bad. Alright, what is a times a squared? Okay, you have to remember, if there's not an exponent written, it's understood to be to the 1st power. Okay, so let's go back to green. This is 1 plus 2, 3. So this is a to the 3rd power, and then b to the 6 plus 3, b to the 9th power. And that's our answer. Negative 28, negative 28, a to the 3rd, b to the 9th. Okay, before we do example 3, we're going to again look back at some definitions. This is 4 to the 2nd, all of that to the 5th power. Well, what that means is that I would have 4 to the second times 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 4 to the second. I multiplied it times itself 5 times. And we just found out that if it's the same base, that you would add the exponents. So this is really going to be 4 to the 2 plus 2 is 4 plus 2 is 6 plus 2 is 8 plus 2 is 10th power. Now, could you have gotten that answer without working it out the long way? Well, yes, you could have said 4 and 2 times 5 is 10, 4 to the 10th power. In this case, you're multiplying the exponents, and that gives you 4 to the 10th power. Okay, now we get to the real fun stuff. Look at example 3. You have 3 to the second power, to the third power, to the second power. Now what does order of operations say to do? You start with the inside grouping and you work your way out. So this is going to be 3 to the 2 times 3 power to the second power, and 2 times 3 is 6, so this is 3 to the 6th power, and all of that is to the second power. And then it's going to be 3 to the 6 times 2 power, which is 3 to the 12th power. Or if we go ahead and write it in standard form, that's going to be 531,441. Okay? Okay, this is example 4. Express the area of the square as a monomial. Well, how do you find the area of a square? Well, area of a square is equal to its side length squared, right? So this is really, what is the side length of this square? 4AB. So I'm going to take that, all of this is the side length, and I'm going to square it. Now this is just like kind of the distributive property where everything in these parentheses is to the second power. So it's going to be 4 squared, a squared, b squared. And we can simplify 4 squared because that gives us 16. There's nothing we can do with these. They are not the same bases. We cannot add the exponents. So it's going to be 16 a squared, b squared. Okay, so the area of the square is 16 a squared, b squared, square units. The square units means that it's the squares, the number of squares it would take to cover it. Okay, let's look at example 5. Is this not totally awesome? We're going to be able to simplify this, and it's going to make sense. So we're going to start with the first set of parentheses, and we're going to take and we're going to square, or take to the second power, each number or variable inside. So we would have 1/3, and we're squaring it. We're going to have x squared, and then remember, a power to a power you multiply, so that's going to be y to the 8th power. And then we're going to multiply it times everything here is squared. So it's going to be -6, I'm going to put that in parentheses, squared, y squared, and then all of this is to the 3rd power. Now, if you put -6 squared in your calculator and you don't put the -6 in parentheses, what the calculator does is it takes 6 squared and then makes it negative. But is negative 6 times negative 6 a negative number? No, so be careful how you put that in. I'm going to work this out. Remember, 1/3 squared means 1/3 times 1/3. So this is going to be 1/9 x squared y to the 8th. And here I'm going to have a power to a power you multiply. So I'm going to have negative 6 to the 6th power y to the 6th power. Now's where it gets really fun. I'm going to work this out and I'm going to put it by the 1/9. So I have 1/9. Then if I multiply negative 6 times itself 6 times, I get 46,656. Okay, that was negative 6 to the 6th power. Notice it's positive. Now, I would have x to the 2nd, and then y, same base, I can add the exponent. So that's going to be 8 plus 6 power. Now, when I multiply 1/9 times 46,656, I get 5,184 x squared y to the 14th power. Now, I want you to think about what you did. You took this and you simplified it to this. Good job.